Good morning. Now we are going to see about the 555 timers. Why we need to study about the timers? There are different types of application where we are using a timers for providing an oscillations like that. We need a timer in a circuit. In every day, the timer in every electronic items, a timer plays a major role. So how does it operates? It operates in different modes. So we need to know the operation of timers and how does it operates. Mainly IC555 timers are used in all type of electronic devices. This 555 timer is made up of diodes, transistors, resistors. For providing a vibrations or oscillations to these circuits, we are using a timer. So the 555 timer is constructed for operating in a different modes as astable, bistable and monostable of operations. This is the pin configuration of IC555 timer. The first pin, there are 8 pins in the 8, this is the 8 pin configuration. Pin 1 is connected to the ground. This is a fixed in which this is the fixed thing which is designed for 555 IC. The first pin is ground. The second pin is trigger. Trigger is that when you give a supply to the trigger, when you give a pulse to the trigger, it sets or resets the timer. For operating the set condition, we are turning on the trigger. The next is the third pin is the output pin. From this pin, from the third pin, we are getting the output of the timer. Fourth pin is the reset pin. Once you give input to the reset pin, the timer is set to 0. Then next is the control voltage, fifth pin. Fifth pin is for control voltage. This controls the voltage for setting or resetting the flip-flop, which resets the timer. The next is the threshold pin. In this threshold pin, it resets the, when you give a supply to the threshold pin, it resets the flip-flop according to which this a set and trigger and threshold supply is given. Your timer operation will vary. The next is the 7th pin is the discharge pin, through which you will discharge the supply to the ground. Then next is the 8th pin is the supply pin, that is VCC. We will say plus VCC. You will give a input supply of 4.5 volt to 15 volt. Your timer, IC555 timer will operate when you give a from the range of 4.5 to 15 volt. So these are the pin configurations. When you give a supply to a particular pin, your timer will work for different states. There are different types of operation states for timer circuits. One is astable, monostable and bistable. In astable mode, there will be no stable state, that is you don't want to control the voltages. You will be getting a continuous oscillatory signals. So your astable state of a 555 timer can be said as oscillator. So this is the configuration in which you will be connecting a resistor, capacitor to the pins. So why the name 555 timer has come is that it will have a 5 kilo ohm resistors present in the 5 kilo ohm resistors present in the circuit for controlling it. So this timer circuit is called as 555 timer circuit. This is how it is named as. The next in this astable multivibrator or astable operation of 555 timer, you will be giving a supply to the 8th pin and ground to the first pin. In between, what happens is that in the 4th pin you will be connecting a resistance, external resistor, which will control the states, stable states. But in this resistor, it is directly connected. See, your pin 2 and pin 6. Pin 2 is trigger pin and pin 6 is threshold. These two are shorted This means when your capacitor is in charging state and it will go to discharge, charging, discharge, that is it will be, this capacitor will be continuously charging and discharging. So this state is not a stable one. It will be, you will be getting output at all the periods. So this type of operation is called astable mode of operation for 555 timer. Next is the monostable state. In the monostable state, what happens is that it will act like a push button. Once you press the button, your timer will be in on and it will get automatically off. At a certain period. That is, when you press the button, your threshold pin, your trigger pin will be in high. When you press this button, this will become low and your capacitor will be charging. Once it is charged, it needs to discharge. So your sixth pin will automatically be high and this charged capacitor will get discharged to the ground. This is how your monostable operates. Once it reaches 2/3 VCC, your capacitor will automatically change its state from charging to discharging and discharging to charging. In monostables, in all the states of 555 timer, what is the thing is that there is a control voltage, as I said. When your capacitor connected across the threshold or when your pin 6 is reaches greater than 2/3 VCC, this should be discharging. A capacitor across the threshold pin should lead to discharge condition once it is greater than 2/3 VCC. So it should be turned off. Threshold pin should be turned off when the voltage is greater than 2/3 VCC. Your trigger pin in this, it is when it is less than 1/3 VCC, it should be turned on. This is the condition in which your control voltage is supplying the voltage for charging and discharging the capacitor. In astable state, there is no means of turning off and on the discharge pin. It will be continuously charging and continuously discharging. There will be no means of controlling. In monostable state, in this there will be a control parameters in which when your capacitor reaches 2/3, when C1 reaches 2/3 VCC, then it should be discharged to ground. The supply should be discharged to ground. Thereby the capacitor discharges its voltage to ground. When the threshold pin is high, when trigger pin is high, then it should be greater than 1/3 VCC. When it is less than 1/3 VCC, we need to turn on the C1 to charge the capacitor. It should be turned on to charge the capacitor to reach 1/3 VCC. When it is greater than 2/3 VCC, it should be discharging. When it is 1/3 VCC, it should be charging. So this is how your monostable state operates. Once the push button is pressed, that is once you give a trigger pulse a high value, then your monostable state will automatically generate a output high value. Then during a certain for a certain period of charging C1, after once it reaches 2/3 VCC, it automatically goes off. So this monostable type of timer circuits will be used for a single state of stable state operation. Once it is turned on, it will turn off automatically. Yeah, next is the bistable operation of IC 555 timer. In bistable state, there will be a two control state. In this two control state, one is for controlling second pin trigger, another is for controlling sixth pin threshold. See, that's why your pin, your one push button pin will be connected to second and other will be connected to the reset. Once you turn on the supply by supplying a positive voltage of plus 4.5 volt to 15 volt, your timer will be turned on. Once you give high pulse to the trigger pin, it will turn on the circuit and a capacitor starts charging, and once it reaches greater than 2/3 VCC, it should discharge. So if you press the reset button, your capacitor will automatically be discharged. So it is by controlling by means of two switches. One is by means of supplying a trigger pin, another one is by means of supplying to the reset pin. It resets whole the timer. So this LED light will indicate during when this light glows, your capacitor is in charging, the period for charging the capacitor. Once the light is in off condition, your capacitor starts discharging. This is how we will be identifying the charging and discharging state of the capacitor in the bistable mode of operation. In astable state, there will be no controlling, external voltage will not be there. In monostable state, only one control parameter, that you will be controlling the voltage through trigger pin. Then in the bistable, you will be supplying a control thing to the trigger and the reset pin. Once this condition is given, your timer will automatically operate for charging and discharging the capacitors. Your next topic is display systems. There are different types of display systems are available. One is LED, LCD, liquid crystal display, light emitting diodes. These types of display systems are available. Now we are going to see the LED display system. This we have seen in often in a day-to-day life. This LED display system will be, this type of display we will be seeing where we will be displaying the letters A, like this. Here letters will be displayed. In this we have seen in every day-to-day life. So the name for this type of display system is LED display of 7 segment, because it has 7 segments, 1, 2, 3. This type of segment display system is called as 7 segment display system. So what will be there in the 7 segment display system? It works based on the principle of light emitting diode. Light emitting diode will be placed in the each segments. Like this, light emitting diodes will be placed in the each segments. This 7 segment display also has configuration of 8 pin, 16 pin. When your digits for display increases, your pin configuration also increases. So there are 2 types of configuration 7 segment display. Here in this normal thing, we will consider this as A, B, C, D. Each segment is A, B, C, D, E, F and G, and there will be an additional one representation will be there, that is DP. It is an this is also that here also LED will be there. How your LED works? It is based on the principle of photoelectric effect, we can say. But in photoelectric effect, what happens when you give a light energy to the electrodes, that the electrons will flow from anode to cathode. But in 7 segment display, the same thing, when you supply a voltage, when you supply a particular certain amount of it, this also operates the same as that of the PN junction diode. When you supply a voltage here, in this there will be the electron hole recombination takes place in PN junction diode. But for light emitting diodes, electron recombination or hole recombination takes place. That is, two electrons will collide or bombard, which emits radiation, that is a light radiation. Light will be emitted. Similarly, if the charge of same charges when collide or when it comes together, it will generate a repulsive force. Because of that, photons are emitted. That photons are reflected as, photons is nothing but a light energy. Light energy is reflected. So this is how your light emitting diode works. It is inverse of photoelectric effect, we may say. When you supply a voltage, light energy is emitted. This is because of electron recombination or hole recombination. This is how your LED works. So this principle is applied here, where your LED is placed in segment A. One LED will be there. Segment B, another one LED will be there. So there are two types of configuration, as I said, for 7-segment display. One is common anode and common cathode configuration. In common anode configuration, what is that? We all know that the diode has anode and cathode. In common anode configuration, here anode, all diodes whose anodes are connected to a common pin. See, this is anode, this is cathode, anode, cathode, anode, cathode. See, there will be no connection between these things. This. All your anode pins are connected common, and you will be having a separate cathode. So if it is of common cathode configuration, all your cathodes will be connected to ground. Connected to a common point. And connected to one, and the supply will be given to anode part, separate supply will be given to anode part, and because of that your light will be glowing. How you will be giving a supply to the 7-segment display is that you will be having a switch in which a external resistance will be connected to avoid the damage for the LEDs. So if you want to, this is like this, A, B, C, D till F, you will be giving supply to the anode of the diode by turning on the switch. This A will be connected to this A and your LED part will be glowing. For displaying the number 0, the switches will be turned on as A, B, C, D, E, F. For displaying letter A, we will be displaying A, B, C, D, E and G. Likewise, your 7-segment display can be turned on and off by turn on the into individual LED. This will be connected, this thing will be interfaced with a microcontroller that will give signal to the switches, and that will turn on the each segments of the LED display. This is how your digital display system works. There are two types of display system, anode and cathode configuration. In each thing, in anode configuration, anode will be, all the anode terminals will be connected in common point, and the cathode will be grounded separately. If it is of cathode configuration, all the anode will be given a separate input and your cathode will be connected to the ground. All the cathode will be combined together and connected to the ground. This is the two types of configuration for 7-segment display. These things, all the timer, anode configuration or cathode configuration of 7-segment display will be interfaced with the microcontroller to display the outputs and give the vibrational inputs. We will interface this with the electronic controllers, that is microcontroller. Thank you.